ಹಲೋ ಹಲೋ.
Kusang kuliah jauh.
Please, congratulations, sir. So you are unable to present the screen. Please log out and once again, sir, and try present the screen. Thanks. Dear participants, resource person will soon log in again. We request you to turn off your video as well as mute your audio so that there will be no interruption during the session. Thank you. Somewhere, sir, can you please retry to present the screen, sir?
is. So at that point of time, you were purely mechanical. Your whole software industry was mechanical without any software. Okay. Then there was a shift to, where your automotive sophistication in your automotive industry has embedded controls. There are a lot of you know softwares which you are focusing on V2X or things like there's a lot of tasks going on, or on tasks going on. Electrical, more primarily electrical. When there were a lot of electronic involved now in the automotive industry, so now there has been a lot of shift to software in automotive industry. Uh, these things cannot be done through analog circuits or analog grids or through a conventional circuit. So, through a conventional method. There's a lot of shift to. So now what's happening is all the hardware, all the hardware that has been proved in the industry. Most of the hardware cars or automotive that has already been proved and work really good. Lost software which is going on. Now your full vehicle control, your full vehicle motion is in the hands of software. So now criticality of software is very important in these scenarios. So there is a lot of other aspects also that we need to consider when we are doing an automotive embedded development, other than what we are doing conventionally for other industries like your industrial places or your IoTs, because in all these industries, nothing is very time critical. It's not that the reaction should happen within milliseconds, or it should happen in like within in nanoseconds. Like that, those time critical, time foundation things are not there. So it is a you can say hard time. There is like in I think in people who are from embedded background, there is they would know that there are two types of deadline are there. There is one is the hard time and one is the soft time. In hard time, when your process should happen within that interval, otherwise there would be a critical failure in the system. Soft time, okay, it is recommended that it should happen in that within particular system, but even if it not happens, it will not lead to a fatal error. So there are a lot of constraints like this in automotive development. Now, what are the main software areas in automotive development? Okay, so till these recent years, if you see all the lists, ADAS, engine control, brake control, automotive gears, active and passive safety, lighting, info system, navigation, car-to-car communication. So till this time, your lighting, info system, navigation, those were very critical, not critical, but those were the main areas in which a lot of work in software development was going on. Because these systems are not very critical, and because electronics are very used to be very uh, I would say not in that exact context, but it was like Chinese items. Okay, it चले तो शाम तक नहीं तो रात का means चले तो चांद तक नहीं तो शाम तक means it can fail any time. Okay, you buy something today and it can stop working at the evening only. So electronics were also perceived in that way because they were very sophisticated, they were very unreliable, uh, architecture had not been finalized. So those these electronic software development were involved in non-critical areas like lighting, infotainment, navigation. That even if these things go bad, it's fine. But now when your software has stabilized, your software stacks have stabilized, uh, okay, these stacks have stabilized. So now they are being used in the critical areas of the vehicle as well, like engine control, your brake controls, your gears. Okay. So now these are active part of a moving vehicle, which are helping in the movement of the actual movement of the vehicle. And then apart from there, like these are the things which are part of the car, which which are inside the car and it's making it move. Now there are many auxiliary things being added like ADAS. In India right now, all your major big tier ones like Continental or Porsche and many other tier one suppliers, these cars are heavily focusing on ADAS systems. ADAS is assisted driving, assisted steering. So in this assisted driving systems means you get all the notifications, your all the environment things, all these inputs you get onto the vehicle. Okay, like I think recently if you would had seen the Tesla video. So hello, I think someone is discussing or some mic is on. Oh, okay. Yeah, so please turn off your mic if somebody has their mic on. And Oh, hello. Okay. Okay. So I was talking about that first are these three: lighting, infotainment, navigation. Okay. Uh, like these three: lighting, infotainment, navigation. These are non-critical aspects of the car. So in this software development was happening earlier also, like even in your older Maruti cars. And so there was some sort of integration of all these things, like controls were there on your steering for controlling the lighting, for changing the music, turning on the map. And then these things started coming up. As soon as the software becomes more stable and more advanced, and they were more reliable. So then engine control, brake control, automotive gears, active and passive safety, means all the safety related things, all the things which are very critical to the functioning of a car. Those things become very critical, and they started, coming up in the software in industry development scope. Now, after that, now some value addition needs to be done. So then these ADAS systems. ADAS means assisted driving systems. In assisted driving systems means your all your environment, you know, information, like if there is any, if there is a lane, or if there is any sign of with the use of radar, then there is lidar. Okay, how far is the object, estimation of those things. So those are mounted, and your vehicle is covered with those things. And there is an assisted driving environment, that where you can it leads to an autonomous car, that slowly it goes to an autonomous environment. Then then there is car to car communication. Car to car communication means, now if you see, we have achieved some level of autonomous vehicle control. Like if you see recent Tesla videos, or if you see recent Google videos, so there are autonomous cars there. So now, if you have a car which is autonomous, we have one car, and there is now another car which is also on the same lane and which is also on the same trajectory. Now you can do a swarm sort of thing, that you can control a swarm of cars with a single set of commands. So this requires a lot of car to car communication. Okay, that if you can operate your a fleet of cars, like 6 7 cars, as a single being. So when you are doing in those fashion, then you need to have very good car to car communication. So that is also, these are usually like very nascent areas, which have come up very recently in the uh, software development in automotive environment, ADAS and car to car communication. Okay. So these are like basic areas in automotive development. So whenever you are talking about how the software development, or what are the things which we actually work on in automotive environment. So these are all the things. Now, there are, what is the challenges you face in automotive development. Now, always remember that whatever coding you are doing, or whatever software industry, uh, maybe if you have been in this industry, and if you have worked in the industry or in any other industry, then you would know that your software development in automotive is not similar to what we usually do in other industries as well. How the software development in general happens. Like if any of your software is going inside a car, okay, if it is sitting inside a processor or a memory or a EEPROM inside a car, then the norms become very stringent as to what kind of software can go inside it. Okay, like supposedly, I will give you an example. Like supposedly, I have a software, okay, in my laptop through which I can, get the information of my vehicles which are on the street. Supposedly, I have 7, 8 vehicles in my area, and I'm getting those information in my system. Then that software is not that critical for it because it is sitting inside my laptop. It is not it is not controlling the functioning of the vehicle. But if something is getting inside a vehicle and it is controlling the aspects of it or its motion or its performance or its behavior, then there is very strict guidelines as to how the software should be written, what should be the structure of software, and how it should behave, and what should be its test cases. So no bugs in serial software allowed. Like in the softwares which are going inside a vehicle, they should not have any bugs. Like I will tell you, most of the software industry that you work on, whenever we compile a code, if warnings are coming, fine. If errors are coming, that you try to overcome. But in a serial software environment, there should be no warnings, no errors, and that is a huge, you know, criticality. Though it may seem no software should be bug free, but when you start really working on it, and your code should be of lakhs of lines, there would be lakhs of lines written in the code, and there would always some sort of bug, some sort of warning, some sort of exception handling or something like that will creep in. So in other industries, like if you are making a mobile app, your mobile app, if it is working fine, uh, how it is working, that is not the headache of tester, that is not headache of developer. If it is working, if it is giving you the output, fine. But in automotive, you cannot have that. If there is a bug which you have captured and which you have got or which is reported to you, okay, you just cannot ignore it. You need to tackle it. Then there is a real-time communication network. So all the communications which happen inside the vehicle, like inside your vehicle, you have lots of ECUs which are communicating with each other all the time. Okay, like your steering system is talking with the engine system, and it is talking with the VCU, which is the vehicle control unit. And like inside the vehicles, there are a lot of communication is happening, and there is only one communication protocol in vehicles means inside the vehicles, and that is CAN. Like CAN is the most critical, communication protocol in automotive. Like if you say that you are working in automotive industry, you cannot say that I have not worked on CAN, because CAN is very critical in automotive, and all your ECUs, whatever your system is there, if two wires are going out of it and two wires are coming into it, means there is a CAN communication. And so all these CAN communication things and how you are managing those communication network, we have something like IVN sheets, okay, intervehicular network diagnostics. So if you see these sheets are like 15, 20 worksheets are there. In that each worksheet, almost I don't know how many hundreds of requirements are there. So there is a lot of requirements, a lot of complexity it is when you are working in a real-time communication environment for a system. Even for a very simple system inside a car, like even very simple system, as I would say, like supposedly there is some VCU for your headlights, like how your headlights should turn. And if you see in recent vehicles, even in Honda City latest models, your headlights, the beam of headlights, they usually turn when you are changing the angle of the steers. Okay, so there is an ECU which is doing that. That when you are giving it, when you are making a turn, that is going as a signal onto the ECU, and then that ECU is actuating the rotors which are giving direction to the headlight beams. So now that ECU is not just doing this task. It's not just simply taking an input and doing it. It is taking care of your batteries also, like whether your batteries have full charge, whether your engine is still running, whether if it's an electric vehicle, so whether your high voltage supply is isolated. Okay, then it will check, okay, whether any other system, if it is interacting or if it is giving command to that same ECU, or it should isolate, and how critical is it. So these things become very important. So all the systems, all small ECUs, they also have a lot of codependency on other systems. So that's why real time communication network is important. Then there is small capacity of processor and memory. And I think that is true for any embedded development, that we have the smallest processors in the industry. And that is also critical for us. Because we cannot have, big processors like Intel processor we cannot put inside a car, because the amount of power that your Intel processor will take will drain out the battery of the car without even its motion also. Okay, so energy efficiency is also very important, because your whole system is running on a battery, 12-volt battery in this case. Okay, so these things also becomes very critical, that you have processor and memory is also very small. So your code should be as atomic as possible, as straightforward as possible, and there should be not a lot of overhead in your code. Okay, so these practices only, I think when we will go further into the session, will become more clearer to you. Then there is functional safety. Functional safety is a different topic altogether. I will tell you right now, if you want to get a job in automotive in today's world, try to go into this field, functional safety. Because as I was saying, telling you that with the advent of more electronics into the automotive world, safety has become a very, very critical thing. Because when you are, pressing the brakes and doing all the other things, just uh, you give me a moment. Just give me a moment. Am I visible now? And can you see the screen?
Yes, sir.
Okay. Okay. Yeah. So as I was telling, that if you want to go into the software industry, and like this should not be a primary concern for you, but maybe if somebody is interested in that, then functional safety are one of the highly paid individuals in automotive world. Not the software developers, not the hardware developers, not the system guys. Means On a skill set, if something is most valued in automotive industry right now, are functional safety engineers. Because since these all environment is very new, all the systems are new, and everything is running on a software. Your full vehicle, it's each and every motion, it's each and every movement is running on a software. What happens if there is an interrupt error in the software? What happens if there's a stack overflow in the software? What happens if supposedly your current line which is coming to your ECU or some signal which is very critical to the ECU that is broken, okay, maybe by physical means or any other means. So ultimately your rider should be safe, right? He should not be killed if there goes wrong something in your software or in hardware or whatever your case is. So that's the work of functional safety people and functional safety guys, which is altogether a different topic. There's a standard for it. There's an ISO 26262. So this standard is usually for four-wheelers in automotive industry. So that's also a huge document. It has, I think, 7 parts. Each part has its own plethora of topics to talk about. So these things become very critical. Functional safety is very critical. Like I will tell you, uh, think uh, JLR, your Jaguar, they launched, I think, some vehicle in Britain, and they had this ADAS functionality also. And the rider, he was looking at the ADAS system to get the info, and he had some accident, and that ADAS system did not display it correctly, or there was some problem, and he sued JLR for, I don't know, so many $1 million. And the people who were first responsible in JLR were the functional safety guys. So that's why this role has become very critical in today's environment. And there is a lot of requirement for it. That's why there is that's why it's a very niche skill set also. And that's why there is also a high pay attached to it. Maybe, I don't know, if you are looking for a very lucrative job offer in automotive, functional safety is very good. Like, it means it's for you. And then there is security. Security things, because once you have a software involved in your vehicle, so anywhere where there's software involved, and now you have connected cars as well, which means they have Wi-Fi, you can remotely, monitor your car and everything. So once you open a communication channel outside the car, okay, means till the time the car didn't had any Wi-Fi or didn't had any mobile apps attached to it, everything was good. There was no reason, there was no reason for security. Security means if the car is fine, if the car is sturdy, okay, that's all the security you need. But once you open a port for an internet channel or a Wi-Fi or any other means of communication with the environment outside the vehicle, you open up, you open the hell gates for all kinds of hackers and everyone. Like supposedly, if I think in movies and all, they show us, okay, the car is hacked and the car is remotely hacked and everything is riding. So then it means that the car didn't have any security on it, because it should not be hackable. The ECU should not be hackable. All these things which are running through a software system, these should not be hackable. So that's why in India, what is happening right now, security is also a very huge and it's a very time and money investment thing. So they don't usually give access only. There is, they don't usually do anything only. like which can be controlled remotely. Just very basic info or some very limited access control is there. But outside, when there is a lot of car-to-car connectivity and ADAS systems and all those things, so their security becomes very critical. Okay. So these are the challenges faced in automotive development. Okay. Now I will talk something about what is model-based software development. Now, I think everyone of you know about inverters, and it's a three-phase system, and you have six switches, and you do a unipolar switching or bipolar switching, whatever is your requirement, and you have some sort of control, and there is a feedback and everything. But always remember, uh, when you go higher up in the system, means you have a big system which has all these functionality, security things, these things as well. You cannot manually write the code. Okay. Uh, One thing I can tell you, in software industry, usually in automotive, there is no concept like, okay, you're like just writing code and running the system, and you're just like typing the code full time. That's how what they usually you know show in all these movies and everybody seems to think, okay, software development is okay, you keep on writing code. Automotive development, like we as OEMs means people at Mahindra, people at Tata, people at Maruti, you know, people means companies actually involved in selling the cars and making the cars. They don't usually write the software because you only see uh, vehicles keep on coming every year, one or two models, and varied vehicles keep on coming. And yeah, I will tell you the time involved in a full software development life cycle means from its inception to the point of a POC. And I'm saying POC, not even a production code also. It is minimum 1.5 years. Okay. And that to 1.5 years, when I'm saying when you have all the stacks, you have all the tools, you have all the code generators and everything, then it takes 1.5 years. Okay. Because the software is so huge, there are so many complexities that you cannot manually write them. Okay. There is a little bit of manual intervention is there. Okay. You are changing some parameters, maybe adding one or two lines of functionalities, or maybe just changing something here and there. But you are not actually typing the whole code. And I think uh, that's what it should be, because you don't need to reinvent the wheel again. If stacks are already there, softwares are already there, you don't need to reinvent the wheel again. You don't need to write the whole software or do something which is already there in the industry, which is already proven. Like unless it is not something very new. Very new means this is something like research level thing you have done, and now you need to, you know, prove it. Therefore, those things also you have MATLAB, you have code generators and all. Maybe something you are doing like very like entirely new, then maybe you can do it. So, in the software industry, we have a lot of tools involved in it, but maybe these tools are costly. So that's why maybe many smaller scale industries or smaller companies or people who are new to it, they do manual coding and they don't do this model-based software development. But else than that, all the industry follows this standard practice of a model-based software development. So if you see this mm, slide in front of you, okay, so Okay, so here this is called a V-shaped model. Okay, see something like V-shape. Okay, so we have something like first. The first stage is software requirement analysis and management. Means what is actually needed in the software. Okay, 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 I need a software which can run my car up to 100 km per hour. But that's your statement, like that's your vision that you need to run a car. A vision cannot be a requirement. Okay. If you see, there are people, I think so, Bosch, like all these your tier one suppliers, even your OEMs, Indra, Tata, there's a huge dearth of requirement engineers whose sole job means the team of 20, 30, 40 people's sole job is to just gather the requirements and do an analysis. Means, okay, you're saying I need to make have an electric vehicle with it should have an electric steering and but it should not be drive by wire. It would have a manual control. Okay, that's one of the requirements. Then in the next requirement seeing you're saying okay, but that vehicle should also be it should also be controllable via app or a remote. Okay, then this is a contradictory requirement. Okay, because if you don't have a vehicle which is a drive by wire, if it's something like which is physically connected to the actual axle, your steering is connected to the actual axle, maybe through a power steering or something. But if it's actually connected, then you cannot have a drive by wire system and which cannot be controlled via an app or remote control is not possible. So these all requirements, like first of all, you gather all the requirements from your client or from the user and you do an analysis. Okay, these things are possible. Okay, if this thing is there, this thing cannot be done. If this thing is there, this thing cannot be done. Or if these both things are there, so it will take some time. Means you give a very proper picture as to what would be the actual scenario. Because if you see, people will say, okay, okay, we need a car, electric vehicle, but they don't know the actual requirements or the actual things which go on to whether it is possible or not. To do that feasibility check and all those things, this system requirement analysis and management is required. So here we have tools like IBM's rational doors. So this is a very good tool for requirement gathering. This particular IBM rational tools, IBM rational doors. So this tool is for gathering all the requirements and keeping those all in one place. Uh, and so that your system engineer or your other module heads can discuss over it and okay maybe reach some certain conclusion. Okay, then there are your software architects. Okay, once your requirements is freeze, okay, these are the things we can do, these are the things we can achieve, okay, these are the requirements, okay, that you have agreed upon. Then you have software architect. Software architect now will architect the whole thing. Okay, now how to place all the things together. Okay, like where should the control of the vehicle go, where should the safety go, where should the security go, where should the connectivity go, and how all the things would be interacting. Because always remember these softwares, all these small modules also, softwares are very huge, and you cannot just place the things randomly because your software should also be scalable. Like it should not be that okay that today I have made a 48-volt system running, tomorrow I am making an maybe a 350-volt system or a 72-volt, maybe a 72-volt system. It should not be that okay now again from ground zero I'm starting the work. Okay, I will use my same code only, add more functionalities to it, add more things to it, and just make that way. It's almost like it's almost like a Chinese restaurant or any other restaurant. Okay, whether you order paneer kolhapuri or paneer Hyderabadi or paneer butter masala, whatever paneer, they have the paneer ready. They even have the gravy ready, almost. Their gravy, their base of gravy is same. Now you just tell me what you want. Okay, you want kolhapuri. Okay, I will add some maybe red powder to it. Okay, you want butter masala. Okay, I will maybe add some butter to it. So those things will remain the same. Okay, means your base of the software will remain the same. You just add more things to it to do it. So that's why that scalability is very important. So that's why there now this third thing comes up: software high level design. High level design means okay, once you have architected, now how all the things should look like. What would should be the various layers. So for that, MATLAB and Simulink low level drivers. And then that controller will understand very few basic commands. Okay, that will become more clear when we will explore this AutoSAR environment. Okay, so that conversion is required. Then there is code generation, means whatever model you have generated, whatever things you have generated, those all are for your understanding. Okay, these are your blocks, these are things, this is that, everything is there. But there should be something, a C code, because ultimately that only you can flash onto the controller. Means from your C code, your hex would be object file would be generated. From object file, hex would be generated. So ultimately, your deliverable is a C code only. So that is code generation. Once you have generated the code, now you do software in loop testing. Software in loop testing means you have a target based hardware. Okay. I'm not actually taking that software to an actual vehicle and running the vehicle on the road. I have made a simulated environment at my desk only. Maybe I have kept a control board or just not even control board. I have a target based system in my laptop only, and I'm just simulating here. Okay, what are the functions which if I'm trying to put into? Is it working fine? Is it working in that way? Means there is no hardware involved. There is nothing involved. Okay, on the system only. Okay, I'm doing some unit testings and all those things are software loop testing. For that, MATLAB, Simulink, and then this is D-space target link. This is also a very good open source platform. So this is very widely used in all over the industry right now for your testing and software and loop testing. Then there is hill testing. It is written here software integration test, but this is hill testing. It's hardware in loop. So hardware in and speed goat, I think these usually cost 2 crores or 3 crores for a hill setup. So these are usually industry level software. I think maybe in colleges also they are trying to go, and because these simulation setups are very good uh, to actually give you a feel of the real environment of how the system will behave. Because anyways, if you have made a proper software, you cannot go and flash it onto a vehicle or run a vehicle. Okay, because that is something. If there something goes wrong, it would be either injurious or your some of your big components will blow up. That's why it's not that much, allowed. Then there is software acceptance test. Means once all your these things are done, then you finally take it to your client or your end user or your customer or whoever the person is taking your software. Okay, maybe it could be a system engineer or anyone, and he will take the software into his environment, into his system, and he will do his own tests. Okay, like so once he has whatever requirements he has given, he will verify all those requirements. Okay, it is doing this, it is doing this, it is doing this. Then there is software acceptance test. Once it is done, then there is software release that you gave your first version of the software. So this is a very standard practice across any software development cycle in automotive environment for any system. Means whether it's for electrical vehicle or any vehicle or anything that you see, this is a very standard cycle. Okay, so then after that, if you see, there are various tools also we have talked about. So here I have taken some tools, examples of some tools, and just trying to tell you in brief as to uh, what is the use of those softwares. So there is MATLAB and Simulink. So whenever you are talking about a model-based system, you cannot skip MATLAB and Simulink because all these models are MATLAB models only. Okay, because your vision, what you have inside your head, when if you are trying to put it onto something, okay, for an implementation, you cannot just start writing code. Okay, that's not possible. That's not there. So once you're trying to visualize something, okay, this is my system. So you usually draw it in on a white paper, something draw. Okay, this, there will be my software. Software will do this. Then it will give an output. Okay, then this will go to, and it will give inputs at this, and then it will go to some other module. So these all your thoughts and everything, these are your MATLAB models. Okay, so a little bit like very much more detailed than that, but this is still your vision. Okay, what you are actually trying to do system. Okay, and in Simulink, all the things are very crude. You don't enter much details. You're just saying, okay, if I will do this, something will happen. So that's why when sir asked me to give you some sort of simulation or anything, see, I can give you that also, but first of all, it is I don't have my MATLAB system. Second of all, it's not required also that much, because if you want to see how something is happening, okay, how code is, just do a Google search, search in YouTube, everything is there. And maybe they will explain to you or tell you better than what I'm saying. Okay, like how those MATLAB is working or how this MATLAB is actually working. Maybe I will show you something, or but here also what I will do is maybe I will import a ready-made generated model or some. If I'm making my own model, that would be a very basic model which is not used anywhere. Very basic models are not used anywhere in automotive. Maybe I will do that, but that will be practically of no use to you. Okay, maybe something, okay, this is how MATLAB works. If you want to see, then that's fine, but that should be actually be a practical use. Then, okay, once you do those things, then you have these tools like embedded code. Embedded coder is also a MathWorks tool only. It's a plugin of MATLAB only. So now you enter the information of your target-based software. Means you have different kinds of controllers also in your environment. It would be something like from Infineon or from Texas Instruments or from Renesas. So um, based on those controllers, maybe you need to generate a code, or based on a specific set of things, you need to generate a code. Specific set of tool is there where you are generating. So for that, embedded coder is there. Means whatever your MATLAB model is there, your embedded coder can directly generate code from it. Okay, means it will generate a C and Sci code for it, which can be then integrated onto the system. So these two usually are called as ASWs. Like if you see anywhere some software profile or something, so these are called usually ASW, application specific software, ASW. Then you have this Eclipse ID. So this Eclipse ID is nothing but whatever C code that you have generated that you can view. Okay, your full C code, that is just a code editor. Okay, supposedly if you want to change something manually, okay, some small maybe a variable you need to add for your own debugging purpose or something like that. Then this Eclipse ID is there. That this is a full C based software. This is a full C software. A full C software. C code editor. I think is not good. Okay. This is C code editor. Then you have vector canoe. So this canoe is on something like when you have the vehicle, okay, and you need to test or simulate or something. So canoe is from name only you can get can is operating environment. So all the CAN signals, because all your communication in the vehicle is happening on CAN, through CAN, via CAN. So once if you are able to tap the CAN channels, then the whole plethora of information you have. But problem is your CAN signals, if you start going through your CAN, like how CAN communication works, so those are usually 8 byte fields are there. They have almost 11-bit identifier, 29-bit identifier. It is a 64-byte frame, and your frames only would start keep coming. And and we are not in a matrix that we can see code and visualize things. So for us, these Canui tools, these raw data, they convert those things into meaningful infos. Okay, that you can actually, okay, speed, those things, speed, current in a running vehicle. Like whenever somebody is taking data in a running vehicle, means he is using a Canui tool. All your service centers, once you are connecting something to your onboard, some plugin you are doing, means you are tapping the CAN channel. Okay. Whenever you are putting something in an interface to your vehicle, either you are doing or your maybe service station guy or your any mechanic is doing supposedly, he is tapping the CAN channel. Okay. So that is Vector Canoeing. It is a tool by Vector. Then there is Trasos, Inca, DaVinci, Target Link, and these things I have already told. Okay, these are uh, these all, not Inca. If you just remove Inca and uh, Trasos, DaVinci, uh, and you can say embedded coder. Okay, these are all the development tools. Okay, so these are not the only tools. Like if you can see, uh, similar to Trasos, you have a tool from Vector also. Like Trasos is a tool of Electrobit, which is a continental subsidiary. So similar tools you have from other vendors also. So these are the most widely used tools. Okay, so Trasos do like MCAL configuration. MCAL configuration means your microcontroller abstraction layer. Means software stacks which are talking to the microcontrollers. So in my previous company, I used to do all these things manually. Okay, because there the systems were small, requirements were fairly simple, and everything was straightforward, and software stacks were very small, and there was no much criticality or anything. So all these things, we were doing on like directly. I was opening this Eclipse ID, okay, opening the C code and doing all this uncal configuration, everything on the C code itself. But now, as your software starts becoming complex, as we more go into automotive world and hundreds of things start coming up, so then you need these tools. Because otherwise, if you start manually writing the code, first of all, you would be wrong. Somewhere or something you would miss, somewhere or something you would do wrong, or some human error will creep in. So that is like to avoid that these tools are required because as we know, there is no margin of error in automotive environment when it is directly going inside a ECU in the vehicle, which is controlling the function of the vehicle. There is no margin of error in that. So these things we usually it is not done through manual coding. All tools will do because tools they will take care of multiples of things which we don't even know about. Okay. So, okay. So maybe if you have something to ask me or something because I think again just I will go through some of the tools and some AutoSAR things. So maybe if you have any questions to ask, you can ask maybe. If any questions are there or if any things are there that you can ask. Okay. Uh, right now, I'm not seeing any questions here. If any questions are there, or anything related to industry, or how this software development works, or anything, not just whatever I have told. If any general queries are there, because uh, I don't have much more, like just some tools things are there, some AutoSAR things, some tools things, then I think my session would be over. So if you have any questions, because actually I'm not a professor here, I don't know that much to speak also. Yeah. Okay. 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 Then 5 minutes. I will just wind up my full session and okay. 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 So, uh, okay, this embedded coder I have already told you. If you want to, see how is this thing like, then get a basic aspect of it. You can just go and watch this YouTube video. Okay, there's the link for it. Maybe I will forward you the presentation after it. You can go and watch a YouTube video for it. Okay, so this is a very basic model, MATLAB model for a PWM motor, how it actually looks like. But I can tell you, nowhere in the industry we have models like this. If like this is what you will get if you will Google the you know things. But wait, I will just show you uh, how an actual model may look like. You know, um, this is this is something like in how in actual software environment, how is the things are there, how the tool is there. So, okay, wait. Okay. So this is actually how your software looks like in an automotive environment. You know, and this is a very basic model. This is a very basic model, means this is the most outermost layer. If you keep on clicking on each and every window, no, more things will keep on popping up. Like double click on this, it will go inside. Double click on this, it will go. So this is a very basic model, and this is a directly code generated model. Okay, so in actual systems, in actual environment, this is how the model looks like. I'm giving you an idea, and this is all the documentation for it. Okay, so in your this is actually one of my previous projects, so that's why I showed you. Okay, that was just a glimpse of actually how the models look like. This is the very atomic model, means the final model which you have there. But for that also, each and everything, each and every parameter, you need to give more information. Like this will just give you an output of the simulation output, because here they see they are using a two-level PWM generator, which is I think doing a bipolar switching to the universal bridge. And this universal bridge is nothing but I think six PWM switches with three legs, which is given to an asynchronous machine. And then this is your angle measurement thing. where your slip and all those things are calculated. Okay, through these Fourier transforms. Whatever your this thing is coming, your ID IQ divided by that this is giving as an input here, and this is your actual machine. But this is a very crude and basic model which can be used maybe for academic purposes and maybe for very beginners in automotive. But in real development, there will be a lot of signals, lot of safety, lot of other interfaces, code generation parameters, and everything. So this is just for proving a model. Okay, this thing can work like that. So this is ASW architecture in a real project. How this way. So this is also very basic model. No, not a very basic, very high level model. Very high level, where you can just see, I think, six interfaces. And if you see so many signals and so many interfaces, all these dotted lines are showing interfaces. All of these dotted lines are showing interfaces here. Okay. And then this canoe, I think I have already told. So what this canoe is. Then we have tools like Inca. Inca is used for mainly calibration. And when you have a system running, means okay, I have released the software and I have given the software, and now it is in testing, maybe hill testing or actual vehicle testing, or it is in those phases. Then we use tools like Inca. So where all the calibration parameters and everything, like supposedly I want to increase my torque from 20 Newton meter per se to 40 Newton meter. Then I will not write again the code, okay, to change the parameter and this. Once this system is there, it is running. So I will attach a CAN tool. I will open my Inca software and I will just give the command on the go. Means electric vehicles I can run without even the usage of any brake, steering, gear, anything. I can just use my laptop, connect Inca, and control the full vehicle. Okay, so these are usually using calibration and test methods. Then this AutoSAR is not actually a tool. This is actually a structure as to how the software is written. Okay, means what are the various layers in the software. Okay, so this is a global development partnership of automotive interested parties founded in 2003. So this is AutoSAR is an open source environment in which you have people from all over the automotive industry, like Daimler, Bosch, Continental, your BMW, Mercedes-Benz, Honda, means all the big players that you can think of. Then apart from that, from India, I think we have people even from TCS, Tata Consultancy Services. Then we have people from L&T Technology Services. Then we have people from even Mahindra as well. Okay, so it's a huge consortium of all the leaders in automotive space, and there they try to standardize a structure of actually how the software should be written, because it cannot be proprietary, because once I write the software, it will be tested by a tool made by some other software. It would be a run on tool made by some other software. It would be hill tested made on tool by some other software. So if there is so much discrepancies in that, then it will be very difficult to develop. That's why we have this AutoSAR standardized architecture, and this is the basic layer. There's a website called autosar.org, autosar.org. You can go there if you want, and all the documents, all the layers, all the service layers, these are open to all. You can just go, like, all the information is free of use there. You can go through any of the documents you want of how actually this is. Maybe it will be a little bit complicated to you, or little bit if you're not from software background. But if you know C programming, if you have worked in a Linux-based environment, then all the things will make sense to you about how all the things are there, and all the softwares are written right now in AutoSAR. actually. So recently we have been shifted to adaptive orchestra because with this ADAS and everything. So now the classic platform is not able to utilize those full potential. Now we have shifted to an adaptive environment. Okay, so I think that concludes my session. If anybody has any question, I will be willing to pick up. Otherwise, I think we can wrap up this session. Yeah. Okay. So functional safety in India right now is being conducted by TUV SUD. Okay. So it's a German organization which gives you certification. So it will give you a level one certification. Okay. And for that, you need to have some automotive level knowledge, though it's not pre-mandated, but you can have some knowledge for that. But like right now, I am level one certified. But as you go from level one to level two, then you need some years of experience working in that field, maybe 2 years, 3 years. And in some specific cases, like you should have worked on HARA, like there's a thing called hazard analysis and risk assessment. There is some PSR, functional safety. So these things should be there, in your experience. Then you can go for level two, level three. So right now in India, I have not met a single person who has gone till level five. Level five means he's an expert on functional safety. He's an SME on functional safety. Mostly, even in organizations, we usually see functional safety level one or two, maybe two. At max, at higher managements, people who are, heading the functional safety groups, those have level three, but nothing higher than that. Like I have seen, maybe people would be here in India right now, maybe with functional safety level five experience, but I have not seen it. So I would suggest don't go directly for certification because these certifications are very costly. These certification will cost you, I think, like I think it would be in lakh something. Okay, so and it will not, if you are looking for just for making a switch in the company like that, don't do it. I would suggest maybe get into an organization, huh? And then maybe okay, show that you have interest in this field, or maybe gather some training materials or something like that, and you can pursue your this thing in functional safety. But it's a very good field. It's very high in demand right now, and we have like there is a dearth of engineers in functional safety areas. Yeah, this one apart from it. Anything else? Any? Okay. Okay. Thank you. Thank you. Thank you, everyone. Okay, I will log off. Thank you. Thank you, everyone. Okay. Yeah, good morning. Okay. Yes. Sin, yeah, in aircraft, you have more criticality, okay, and it is like it is on next level with the automotive. Like there is first aircraft, then on second level it comes automotive safety, then on third level. So that is, I think, in aircraft that's a totally different area only. It's a totally different area. Your safety and all those are like totally different areas only in avionics. Yes. Yeah, yeah, yeah. Yes. Okay. Okay. Okay, sir. Okay. Yeah. Okay. 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 Sure, sir. Okay. Thank you. Thank you. Yeah.
Hello, Soumya madam. Very good afternoon. Yes, madam. Yeah. So, yeah. So what's my timing, madam? It's like between 1:15. Okay. Sure. Yeah, ma'am. Yesterday there was a problem in the network. No, no. I'll only share that because it becomes an unsynchronized if I share the PPT and you will not be. So I'll operate from here only, madam. Yes. Thank you.
So, one
Hello, sir. Sanjay, sir. Sir, PPT is not on the screen. PPT is not on the screen, sir.
Yes, sir. I am sharing now, sir.
Okay, sir. Okay, sir. We can start the session.
Yeah. Sir, magnetic interference. And cell phones, welders, motors, LED screens, and likely to disturb the operation of one another. So here, the emission may happen from one device and it is going to affect the other device. So that should not happen in all the cases. So what are the different ways to minimize the EMI and EMC? That we're going to see in the coming slides. Now, what is EMC? So EMC is the measurement of a device ability to withstand for operating environment conditions in the electromagnetic radiations where it is happening. So evaluating how a device will react when exposed to electromagnetic energy is one of the most component of this, known as humidity or susceptibility. So if there is no humidity in the device, then it is not going to withstand for EMI signal. Electromagnetic interference will happen, then the device may fail if there is no humidity. So humidity, I'm just going to recall from the current market or current scenario. So if you have very good immunity, your body immunity, then corona may not affect the people, right? So in the same way, immunity is nothing but the withstanding ability of the device for the electromagnetic interference. So here, measuring of the amount of EMI generated by the device in the internal electrical system is known as emission testing. So both aspects of EMC and are important to design engineers considering the good system performance. So this is how this is about the story of EMC. And if you see that, hello. So if you see the definition, exact definition of EMI and EMC, what it is in the very simple words, EMI, it is the result of electronics or magnetic field acting on the device, causing to undergo the malfunctioning of the other devices or failure of some other devices. That's what we call it as electromagnetic interference. And EMC is nothing but the simple definition. It is a withstanding ability of a device in electromagnetic environment without causing effect on surrounding devices. That is called as EMC. So there is one proverb in Kannada, very interesting proverb. Deliye eddu phalamaidu. So that means the device which is protecting, that should not spoil the same system, right? So that is what the link to EMI and EMC. So what is the difference between the EMI and EMC? So hope you understood from the definition itself. That is, EMI is nothing but a result of electric or magnetic field acting on the device, which cause to the failure of other devices, right? Now, who is the cause over here? The first device is emitting, that is causing all the effect, and it is affecting the second device. So this second device may become the effect on, or it may become the affected because of the first device. That is what the EMI. And EMC is nothing but the withstanding ability of this second device or the first device which is already emitting all the EMI signals. So that's what difference between the EMI and EMC. Now it can happen in the reverse way also. Sometimes the second device, what I am showing here, this can emit the emission signal and this can become the receiver. But this should able to withstand for the signal. That's what we call it as humidity. So that means the system is not is will not failure under the circumstance of electromagnetic interference or EMI. Now, this is an example of interesting example of aviation or air traffic control signal for the flight which will take off from one place to other place. Let's say from Bangalore to Mumbai or Bangalore to Delhi. And the pilot will follow the route path which is shown by the air traffic control. He will never take off into other, other than the flight, other than the route path which is already described by the air traffic control. So he has to follow the lanes. Otherwise, there may be an impact on the, or there may be a collision of the flights will happen on the sky itself. So here, this particular red line, let's say this is a path for this particular pilot, which he has to follow. If he is not following, then there may be some provision, or there may be some dangerous things, or there may be a collision may happen. Then, in what way the EMI and EMC are related to this particular factor? So here, this particular slide will tell you that how the EMI and EMCs are going to be affected for the aviation. So hope you might have experienced when you travel or when you fly in the aircraft, or the crew pilot or crew will say that switch off your mobile and laptops and iPods when it is landing and take off, right? Why? Because there will be a signal. There are signals which are coming from the air traffic control signal to the flight and back to the flight to air traffic control signal. So there is a synchronization is there between the air traffic control station as well as the flight. So these devices, the operating devices like mobile, laptop, and iPod, they are also operating at certain frequency. So those radiations, those EMI and EMCs may affect the aviation signals. So those signals, then there may be a possibility of disconnection of the signals, or it may be a failure of or malfunctioning of the components may take inside the flight. So that's the reason they are very particular during the takeoff and landing. This is what the path where the pilot has to follow when the flight will take off. So there, first one is this particular height he has to take. So in this particular height, he can close the landing gear. So then climb reaction height, then flap retractions, then climb to 1500 degrees. So that is what already framed by the aviation traffic signal or aviation traffic station, so that the pilot has to follow. So if there is any mismatching or if there is any loss of the signal, may lead to the path or discomfort or going away from the path may happen. So that's the reason they are very particular about the EMI and EMC effect. So generally we don't understand when the crew pilot or when the air hostess will turn off your mobile, we'll take it as very light. But we, as a engineers or as a known person, we should turn off the flight. We should turn off the mobile, laptop, and iPod during this process of landing and takeoff. So, what is the causes for the device failure, or why it is going to be, components are failed when they undergo the EMI and EMC effect. So, this EMI and EMC effect may cause the supply voltage interruptions, that is, voltage dip, voltage surges, and fluctuations may happen in the power supply because of the malfunctioning of the device, or it is because of mutual effect. Then the device may fail. Then fast transients over the voltage of the supply and signal control lines may happen. Then RF, radio frequency field, both pulse and continuous radar coupled into the equipment on the cables. So this can also happen. And ESD, that is electrostatic discharge from a charged object to the person, can also happen. So this is nothing but a short circuit. So that's there in the coming slide. I'll explain what is the ESD, how it will happen. And a low frequency magnetic or electric fields. So these things can lead to the failure or malfunctioning of the components because of EMI and EMC effect. Now, what are the sources? Which are the sources are causing for the EMI and EMC? So, in the entire network system, we come across all the antennas, then power transmission line, then we have a mobile network, then you have a vehicle to vehicle communication, vehicle to grid, or vehicle to some other, like, different modes of communications are happening. So they are all electromagnetic based. Now, when all these sources are operating in an entire system of, like, geo system in call, so they emit their own radiations. So, but those radiations will be affected to some other devices. That's what the effect is going to happen. And these are all the different sources as I shown in the pictures. So they are all the sources of the EMI. Then how the sources of EMI are classified? So basically, the major sources are continuous interference and transient interference. So continuous interference are nothing but when the source is continuously emitting a noise signal at a given range of frequency. That's what we call it as continuous interference. And transient interference, if a source emits a pulse or a transient energy for a short duration of time, so that's nothing but a transient. But their effect may be very high, but it is only for a very short duration of time. So these two are the major classifications. So among these two further classifications, we have classified as audio frequency and radio frequency. So audio frequency is nothing but the range of frequency we can able to hear, and radio frequency definitely we cannot able to hear this. It's beyond the audible frequency. And broadband is the another type of continuous interference. And transient interference, so that is nothing but electrostatic as well as transient voltage sources and voltage ringing noise. So these are the three major classification in case of transient interference. Now, so the same thing I have written in the sentences, the source of like different sources, continuous and transient. So I'll just go to the next slide. So what is the effect of EMI and EMC? So who is the victim and who is the source among these two? Emitter and the source. So here, if you see the source is this device and victim is going to be this device. Then what are the possible ways that the noise is going to impact from source to the victim? So one is like radiative kind of emission, and another one is conductive. So here in the radiative, the interference EMI is happening in case of air only. So there is no air or vacuum you can call. That's called as radiative. And second one is the EMC is going to happen through the conductive path. The conductor itself will act as a EMC path. So that's what a conductive path. So if the noise signal is emitted in the air or vacuum, then it is called as radiative. If the noise signal is through a conductor or a conductive material, then we call it as a conductive. So this is one simple example how the EMI and EMC will transfer from source to victim, or it can happen in the reverse way also. So if two neighbors are working in the side in an office, so one system is emission and another one is receptor, or please don't link with this and that. So it's like a emission. So we need to have a proper setup for this. So sorry. Second one is radiation emission test. So this particular emission test is done to test the emission in radiation, that means in the air gap. The radiation emission test involves measuring the electromagnetic field strength of emissions that are unintentionally produced by the devices. Yes, unknowingly. We don't know whether the device is producing or not, or like by itself, its own operation only, it is going to be uh, or emitting the radiation that is coming in the air gap or in the vacuum surface. Then how to test that? The radiation emission test is concerned about how much a device is emitting radiation RF, in terms of RF energy, that is radio frequency energy. So this is a test setup. This particular container, and there will be a sensor. So these antennas are made to rotate in this particular container box. So these are the different types of antenna which we can select for the testing purpose. So based on that, for an antenna, the radiation emissions will happen in the air gap. The reason behind making this surface like this, it's like a rough surface like this, the same radiation should not reflect back. It is a smooth surface, and the possibilities of reflecting back will be there. So in order to minimize those things, the radiation emission compartment inside is made like a very rough surface. So that's what the radiation emission test. So if at all the entire setup is going to be developed in an industry or in a college or in a university campus, definitely it is a cost. Cost matters. It somewhere goes around more than 50 lakhs, or it goes to 1 crore also. And if you see the interior of the radiation emission test, as I told, so it is going to be a rough surface. There is no reflection, and here is the antenna. What is being shown is emitting the radiations, and these are measured in the area. So that's how the radiation emission test is being measured. So, and it is being given. So that means this particular device is emitting this much of radiation, and is to be within the well level. Now, the reason behind saying this particular emission test is, as per the standards, your EMI and EMC should be within these particular ranges. So there are several standards, IEC standards, SAE standards, UL standards for different domains. Like if at all you go for the industrial domain, you will have these standards. Information technology, you will have these kind of well-defined structure from the standards only. Medical devices, this is what the range, and wireless devices, this is what the range of signal. Automotive applications, range of, this is what the defined range of signal. Now here, in this particular graph, there is a red mark. So these signals, that is radiation emission, should be less than the defined one. So red mark is already defined one from the system itself, and these other two are actual measured quantities. So these measured quantities should not cross over the defined standards limit. If it is crossing defined standards limit, then the device is not properly designed. Then the product may not able to sell in the market. So this is how the radiation emission test is being performed and validated with the standards which are defined by the standard bodies. Test. Now, immunity to conduction emission test here is, so this particular test is ascertain the level of withstanding ability of the device in the noise operating signal comes from the conductive wires. Once the conductive comes means the immunity is coming, or sorry, the emissions are coming through a conductive path. and immunity in the sense that is a withstanding ability. The noise signal that comes from the conductive wire and conducting path also. So here, this particular waveform is shown in order to test the noise immunity for the conduction. So here, this particular surge is a very short duration of time, but it is at so that particular lightning will, whether the device is able to withstand for this particular effect for a short duration of time. For that purpose only, this particular test is being performed. So surge immunity, the basics of these tests are subjected to voltage spikes on the top of the nominal voltage to the input systems. The spike represents very high voltage like hiccups, high that are caused by the lightning and large motor drives, etc. So this particular transients or what is happening in the system and your device is not able to withstand for this particular uh, very high amplitude signal for a short duration of time, then the immunity of the device is very high, it is able to withstand. Then transient immunity. So as we know that the transient immunity is nothing but number of disturbance in a continuous signal, you can call. This test will ascertain the voltage transient pulse will vary for a short time and has high pulse representation rate. So transient voltages are temporary, unwanted spikes, and electrical circuits. They can either enter from the source or source from the enter, vice versa. So from the source to the destination or destination to source can also happen. So these transient voltages are generated by the turning on and turning off of the devices, some of the power electronics devices or fast switching devices, power factor correction circuits, and so on. These transient voltage can also cause the variation in the amplitude and the voltage in the insulation of the devices. So there may be a possibility of failure of the insulation and the duct cables because of very high transients or a continuous operations. So the insulation may lead to the breakdown voltage or breakdown. Then it may lead to the short circuit or failure of the cable itself. Then immunity to radiation test. Now earlier these two tests they performed for the conduction. Now this is for the radiation. Now there are possibilities that the emission may happen in the air or vacuum. Then whether the device is able to withstand for that or not. So this test will certify the level of withstanding capability of the device from the noise signal comes from the air or vacuum, or air and vacuum is the media. So let's see a person while walking itself. So there will be a electrostatic deposition will happen because of the walking effect, and there will be a small amount of charge is going to be accumulated in his body. So the reason behind showing this circuit board and the person is whenever you operate the work with this kind of very sensitive board, you are not supposed to touch this sensitive board with the bare hands because already the charge is being accumulated in this, and once we touch these devices, it may lead to the failure of the component itself. Very small. So industry usually does not permit in the way what it is being shown. So it has proper way to handle the components. So these four tests are done in order to test the withstanding ability of the device as well as in order to test how much EMI signals are going to be generated from the devices. Now, electric vehicle and power electronics. So hope all of you know that the electric vehicles are full of power electronics devices. When we are dealing with the power electronic devices, the circuit board itself may cause the EMI, and which may lead to the failure of other components or neighbor components in the vehicle itself. So then what is very important, the filters are required, EMI and EMC filters are required in the entry level or wherever it is happening in the circuit board in order to minimize the effect of EMI. So here, let's say this particular figure will explain the input signal will have signal plus noise. So here, the signal is okay, but noise is not okay. Right? It's not required. So these noise may disturb the operation of other devices. So hence, in the beginning of this input signal itself, they need to be filtered out or they need to be rectified, and whatever the required signal is only transmitted to the next level. So that's what the power electronics based filters will do the operation. Again, it's a power electronics circuit only or power electronics devices only. So the surge arrestor, the reason behind showing this particular slide is hope in the power system, the surge arresters or the lightning arresters are usually kept at the starting of the power station or distribution station, you can call. So let's say if you are Nelmangla power station in Bangalore or Shumoga Charavati power station. So these lightning arresters, they are normally placed at the entry level or they are near to the power transformer. The reason behind placing these lightning arresters or the surge arrestor at the entry level, if there are any surges coming from outside, they should be arrested in the beginning only, or if there are any surges happening inside the power station, they should not be left out of the station, they must be arrested there itself. And near to the transformer is, if any surges are happening or coming from the outside to the transformer, because transformer is the costliest device which is in the power station, that must be arrested in the beginning of the transformer or in the entry level of the transformer. So in that way, we need to incorporate the EMC filter or EMI filter, EMI and EMC filter in the beginning of the circuit itself, so that the next part of the circuit or further part of the circuit will not going to be disturbed. Now, EMI and EMC in the power electronic circuits. Consider this is a power electronics SMPS or switch mode power supply, which we normally use in the desktop system. If you open a backside bonnet or CPU, you will find a box-like structure. And if at all you see the circuit diagram of the SMPS, it seems to be like this, and it is the way. So there will be a rectification because our utility is AC. So converting AC to DC. Isolation transformer is there. So if there is anything goes wrong outside, that is not going to be affected for the system. There is enough isolation, and these are all the intermediate devices like DC link capacitor, then coupling resistors, coupling capacitors, and for the proper conversion from AC to DC, and the different level of voltages are required. So you might have seen that there are 2-3 outlet connectors are there, the different voltage ratings. So this particular connector is 14 volts, 1.2 amperes, this is 5 volts. In that way, the several connectors are going to be connected. So this is what the entire power electronic circuit for the SMPS. Now here comes is the SMPS, electromagnetic and EMI and EMC filter. This is nothing but a coupled inductor only. So coupled inductor will act as a arrestor for the EMI or EMC EMI signal, which is coming from the outside to inside the system. That means from the power system to your desktop, you can call, or if there are anything from the desktop to outside, that is going to be arrested here itself. And if at all you see the actual diagram of this, so here is the transformer, which is acting as a coupled inductor, which is acting as a EMI arresting circuit or filter circuit for the electromagnetic interval. Then, as one step ahead, so power electronics devices and electric vehicle. So this is what the pictures which shows the majority of the components in the electric vehicles are the power electronic based components, including charger, DC-DC converter, sensors, mirror, all many components, DC-DC converter, battery management system, everything, almost 80% of the component you can call, they are power electronics based components. So these power electronics based components may cause itself EMI signal, and they may lead to the failure of neighbor system. So then we need to incorporate what type of filters and where for the device. Let us see in the next slide. So this is one electric vehicle charging circuit where we charge the electric vehicle battery, that is HV battery, from this AC supply with all conversion process, that is AC to DC, because our utility is AC, and this DC is inverted back to, or isolated DC, you can call DC-DC converter, or we can go for the non-isolated DC-DC converter. So my main interest is to see the EMI and EMC effect in this particular circuit. When you lay this circuit, when you see this particular circuit in a block diagram or circuit diagram, it doesn't have any kind of EMI EMC. But when you lay it in the circuit PCB, definitely the PCB itself will act as a source of EMI. So then how it is to be arrested? So here is the inductive circuit, coupled inductive circuit in the entry level itself. If there are any EMI signals are going to be entered from the source to here, they must be arrested, right? And if at all anything comes from interior to outside, they should also be arrested, just like a lightning arrestor, what is being shown in the previous slides. So this is what the block diagram, where AC voltage is EMI filters, then boost converters, then DC-DC converter, isolated DC-DC converter, and finally you are charging the EV battery. And it depends on the unidirectional, bidirectional operations. Also, you can configure the circuit for the your required level. But majority of the cases, the EMI filters are going to be placed at the entry level only. And this is another one for onboard charger. So onboard charger is nothing but electric vehicle charger which is there inside the vehicle. So we are directly giving single phase AC power supply to the vehicle to charge the vehicle battery from the residential place. That means from the home where the single phase power is available, or at the office where the three-phase power, where the single phase power is available. You can charge the vehicle from the board or EV onboard charger which is existing in the vehicle itself. That board should also have a EMI filter. If anything goes wrong, or if any EMI filters are coming from the outside world, that means power system, it should be filtered in the beginning, or if at all anything is backside, so that means. So the reason behind showing earlier one and this one, onboard and offboard, is nothing but the fast charger and low charger. Fundamental requirements are similar. There is no difference. So there also we need to design the circuit in the same way. Here also we need to design the circuit the same way, provided your power rating may increase in the offboard charger and power rating may increase in the onboard charger, because we are using single phase power supply for the onboard charging. And EMI filter in the powertrain also. So as I told in my yesterday's example, so powertrain in the electric vehicle starts from the battery. So battery, then you have a coupled inductor, then you have a capacitor bank, then you have converters. So here, this particular, there is a one red path is been shown. That path itself will become the conductive EMI. So conductive electromagnetic interference. So in order to block this one, we need to have a high impedance inductor in the beginning of this particular circuit in order to minimize the EMI effect. So this is what the three-phase fast charging circuit, where exclusively three-phase power is being used, and EMI filters are done at the DC side level, at the single phase. So here three type of same EMI filters can be used in order to minimize the electromagnetic interference. And EMI filters, if you see the laptop wire, so if you see the laptop charger wire, at the end of your pin which you are connecting to the laptop, there you see the bulged kind of circuit. There it's a round structure. Hope you might have seen in the laptop when you connect a charger. So just near to the your connecting pin, your wire is packed with some kind of insulation and it's a bigger in size. So that's nothing but an EMI filter which is coming from the power supply, which should not go to the laptop inside. So this is what the circuit EMI filter. So here input and here it is output of the EMI filter. Now a coupled inductor or a one choke coil, a single coil, that also act as a EMI filter, and another one two, that is coupled inductor like this, as you can see here. So that can also act as a very good filter for the electromagnetic interference. So yeah, I said in the earlier slide, so your laptop charger, and finally you once you see the particular type of block, so this is not a laptop one, this is electric vehicle DC-DC converter. So as you can see here, this particular block is nothing but a filter which will minimize the EMI effect coming from the charger or outside to the converted vehicles or electrically connected vehicles. By the autonomous driving vehicles hit by an electromagnetic waves resulting in the fallout of the crucial systems. That is, the 3D system, electromagnetic engineers can assess the EMC risk, avoiding the catastrophe serious, and ultimately uh, the vehicle has to reach to the safe ride mode. That means at least you can bring your vehicle to safe mode, safe or safe mode in order to avoid the accidents. So in that way, we need to uh, test and ascertain the vehicle has been tested for EMI. So it will not be, it is within the well-defined standards. So what are the requirements? The requirements are automotive simulations. So definitely we cannot do the real-time implementation or real-time before we develop the simulation. So we need to validate the performance of the vehicle or system with simulation model. That is nothing but automotive simulation model. Then second one is ECU design verification and validation reviews. So the whatever the ECU, that is electronic control unit design, should be verified and validated from the experts. So that's what the review. Then creations of automotive EMC test plan. So test plan is required, and systems and system components level of EMI and EMC environment testing must be done. Then automotive EMC testing as per the OEMs. OEM is nothing but original equipment manufacturers at the global standards. So these particular requirements which we need to perform before releasing or before releasing the vehicle to the market. But actually we are not, because of the very crucial laboratory requirement for the test facilities to be done for the EMI and EMC in the vehicle. And electrostatic discharge. I mentioned there is one word inside during the presentation, ESD, electrostatic discharge, is nothing but an electric shock. So electrostatic discharge is the flow of electricity between the two electrically charged objects. So let's say you are touching a object where the charge is being deposited on the surface of the this particular surface of the what you can say block, or you can say almirah, or you can say compartment. So when you go and touch, so there will be a discharge. You will become the path for this discharging of this particular. It's nothing but a shock only, right? The charged bodies are caused by the conducting electric shock, and direct breakdown may happen and may lead to the end of the life also, you can call, or it's dangerous to the risk, dangerous also. So it is the effect of stationary electrical charges built up as a result and contact between the two dissimilar materials. So what is next? So the next is, when we deal with the power electronics devices or the power electronic circuits, so what are the steps which we need to follow when we operate, or when we do the maintenance work or repair work with the power electronic circuit board? As you can see here, when there is a conductive path is being brought very near to the circuit board, there is a discharge, ESD is going to be happen, partial discharge in the air gap itself is happening. So that must be avoided. So this, what is going to happen is, there is a failure of this particular device because of this particular components we brought to very near to that, and this particular device is failed to operate, or it will fail in the board itself. Normally we will not come to know that. And when human interference, or when there is a communication happens between, sorry, not communication, when there is a maintenance operation happens between the electronic circuit board and the user, there must be a proper grounding should happen between the human body to the circuit board. So this is what the grounding cable, which you normally tie up on the hand, and then that has to be grounded to the, so that your body charge should also be neutralized. So the same way, the electric switches, once you touch very near, sometimes you get the electric shock. That's because of electrostatic discharge. Then what is the effect of, as I told in the earlier slide, it is going to give the negative impact on the devices which we are using, like power electronics devices which we are using. Electrostatic discharge or static electricity affects electrical power supply in the industries like data center, semiconductor industries, manufacturing industries, service centers, and ICTs. So these power electronic circuit boards should be taken in a polythene cover where it has got sufficient insulation, so that the small components like this crystal, then microcontroller, then capacitors, and the resistance circuit. Resistance will not be affected because of the charge is the charge in the human body. This is what the protective earth circuit, which we need to hold on our tie on a hand and then use in the way. And if at all it is out of ground surface or on the table, so you need to hold it in a packet so that the small devices will not have affected because of electrostatic discharge. So electrostatic discharge is nothing but an electric shock, which may also happen because of the radiation emission. The radiation emissions on the mobile, but it is not going to happen in a very large way. So in the small effect, which we normally don't see that. So these radiations emissions may induce or affect this particular device, and the charges may accumulate here. And the person who will come and touch, he will be the victim for the ESD. So ESD integration effect in the, so this person, as you can see in this particular slide, the person who is operating in the lab, so he has hold up the ground terminal in his left hand. So that means he has made his body potential to zero, so that the operating device or the device which is used to operate, they are not going to be failed. So I completed this session little early because I want to cover up yesterday's session also. So if any questions from the audience, I will try to answer the question from the audience.
Okay, sir. Sir, I will read out a few questions which is asked by the participants, sir,
Yes.
for you.
Yeah.
Dear participants, please post your queries in the chat box. Okay, please.
Yeah. So good afternoon. What maximum range of extent EMI UMC can be affected by the electric vehicle? Yes, Madhuri Bhagewadi. I'll take one by one. So,
Yes, sir.
Madhuri Bhagewadi, what's the maximum range of EMI EMC can be affected in the electric vehicle? So here, the maximum range is defined by the standard, that is IEC 600151. So it is in the range of the audio frequency, which is in the megahertz, but definite value is given in the standards, which I am not supposed to discuss because it is paid one. But it is in the range of some megahertz frequency. So next question is technical issues. Online session. Very. Could you ask the questions by unmuting yourself? It will be a good, because there are many. Hello. Hello.
Sir, participants have asked the question. So if anyone else would like to have any interaction with the resource person, or you can put the message in the chat box, we will convey the question to the resource person, please.
Yes.
Sir? Hello?
Yes, please. Yes, please.
Hello, sir.
Hello. Yeah, tell me.
As you said, sir, good afternoon, sir. As you told that a natural electromagnetic radiations would cause like whatever the radiation coming from mobile phones or different electronic devices, that may affect to the electric vehicles, sir, in future, because more and more this mobile radiation from the radiation towers, so it may cause any severe effect to the electric vehicles, sir.
Yeah. They may cause the effect on the electric vehicles, that is EMI, electromagnetic interference. But if it is EMC test, so with the EMC test, the compatibility of the device is good or the immunity of the device is good, and that is not going to be filled with that emitted radiation. So that is why the standards will say that the emission of the radiations should be within this particular range. If the range of the emission is within the defined range, then they will not going to cause the impact on the other devices.
Okay. Okay. Thank you, sir.
Well,
Okay, dear participants, if you don't have any other queries to ask, as we have already shared resource person's email ID, you can post your questions over there. Now I request Professor N.G. Atal sir to conclude the session.
sir, one more thing. If there is time permits for me to conclude yesterday's one, so is it possible or it's fine? Hope yesterday.
No problem. You can conclude. You give the conclude.
Yeah, Ajana sir has already concluded because he's a very nice person. So
Yes, sir.
very genuine person in the managing this particular workshop. So I'll just conclude in the last few slides. That is, can you able to see my slides, sir?
No, not visible.
No, sir.
Yeah,
Not
I'll
yet,
share the slide. I'll share the slide.
Okay, sir.
Yeah.
Hello?
Yesterday, yes, sir.
Okay, you can continue the session with answers and questions or anything. Then you can conclude the
Yes, sir.
session.
Now I'm sharing the
Okay.
screen.
Okay.
Yeah.
Okay, do that, sir. Go ahead.
Sir, hope you can able to see the screen.
Yes, sir. Yes, sir.
Thermal management in the diesel car, correct?
Yes, sir. Yes, sir.
Yeah, thermal management. So earlier, so why it is very important to go for the thermal management in the diesel car? So anyhow, we are burning a conventional diesel and petrol in case of the diesel and petrol car. We need to provide the cooling system. But why it is so important in case of diesel car, electric car? Let us see. So this is what the battery. Small batteries are connected in series and parallel configuration, and in order to form the high voltage battery. So till now we don't find very high voltage single battery. So usually we follow the procedure of series and parallel configuration of small batteries and form the bigger one and mechanically packed them. So here, when the batteries are charged and discharged, so there is a temperature rise in the cell will happen because of the I square or loss inside the battery or because of its internal losses. So these batteries has to be cooled as and when it is required. The temperature is if the temperature increases beyond the defined ranges, then we need to maintain the temperature within the ranges only. So these single batteries, multiple batteries connected in series and parallel configuration, and this is how the cooling duct is being formed, and finally in the entire mechanical pack we can see in this way. So the possible places of heat generated in the electric car is a battery, and second one is a motor, or that is motor operating devices, that is power electronic switches. So these devices there will be a rise in the temperature because of their operations. And if at all we left as it is without cooling system, and definitely at one point of time they will be spoiled. So in order to protect those devices, we need to have a good cooling system. Usually we provide the liquid cooling system for electric car, like how we provided in the diesel car. So this is what the normal flow of the coolant, that is glycol, which is taking a continuous one circle of flow inside and outside, and takes the heat which is generated inside the battery pack. And the power electronics devices, that is, if you take an electric vehicle charger, we have a high frequency devices. So those devices must be cooled in order to increase their lifetime. Otherwise, they may be spoiled because of increasing the temperature. So if you see the thermal analysis of the temperature increase in the battery pack, how it is with the ANSYS software. So it is like this. The battery which are very near to the exhaust fan or the fan, they may cool very soon, and the batteries which are away from this fan, they may be still increasing the temperature because of the difference in the system or difference in the cooling rate. Hence, in all the directions, we need to provide the cooling system in order to distribute the uniformity among the air. So this is what the mechanically packed battery with small cells and glycolide coolant is made to allow in the loop structure, just like a transformer fin. So how the transformer crude mineral oil is going to be circulated in the fin of the transformer. In the same fashion, we need to make a continuous flow of the glycol liquid, so which will carry the heat generated by this cell. So battery temperature management system. So this is very important. So the embedded system or the battery management system is an embedded system which includes both software and hardware. The software will define the ranges of temperature for the battery. So let's say the battery operating temperature is minus 45 degree to plus 80 degree or plus 100 degree. So if at all the operating temperature is well within this particular value, then the actuator will take the decision, depends on the reference value of the battery signal and the actual value of the temperature what it is coming out. So this is what the target temperature, and these are nothing but the actual values of the temperature. Now this is what the thermal load or a battery pack where the temperature is being brought out and it is compared with the actual value. And here battery temperature management system control unit will take the decision according to the program what it is being written, and then it will send a signal to the actuator control unit whether to go for airflow cool or go for liquid cool or air fan cooling system. And then heat exchanger will going to exchange the heat between a cold bodies and heat one, and the cold one is entered inside the battery pack and hot liquid will go away from the battery pack. So this is how the cooling system will take place in case of battery temperature management system. So heat sink is very important. So why once it comes to automotive applications, these heat sinks must be in a smaller in size, weightless, but they should do the good job because it is going to be placed inside the vehicle. These are all the different types of heat sinks which we provide for the power electronics devices in case of electric vehicle. But if at all we don't provide the heat sink, there is a possibility of failure of the components will happen. And this is what the heat sink, battery pack mechanical. So why it is required to do the very good mechanical packing of the battery? Because it is automotive applications, it is going to be on the different road conditions. So that means it should be able to withstand for the vibrations and sustain for longer duration. That means the life of the battery should come for the longer duration, at least 5 to 10 years prediction. Then better insulation has to be provided so that the user may not come a severe electric shock. Then air and liquid circulation system is to be incorporated. Maintain the temperature between a hot, cold, and surface. So these are the things which are required to maintain the to increase the battery pack mechanically in a better way. So this is one heat sink how it is being done. Then what for the temperature management system is required? The requirement is to maintain the temperature well within the system, to increase the engine performance, to increase the efficiency of the operational efficiency, you can say, to avoid the failure of the components due to excess temperature. This is also one of the important factors where we need to do the battery temperature management system. And display, like what you have seen in the electric car, diesel car, when a speedometer in the driver level, you see that all components, all the major parameters, that is speed, then what is fuel left out, what is the engine RPM, all those things. Likewise, we need to see the display in the electric vehicle. Then what are the factors? Definitely, we don't see the fuel left out. We see the battery voltage left out. So battery cell temperature, battery cell voltage, minimum maximum traction voltage, and state of charge of battery, motor temperature, or motor RPM, all these data are going to be displayed in the screen so that the driver become alert as per the data. So thank you very much. Hope any questions on this. I'm ready to take the questions on this particular topic. Yesterday we did not complete because of the network issue. Anyone has got any questions on this?
If you have any questions, you can unmute your mic and you can directly speak to resource person. Okay, dear participants, if you are having any specific question, you can ask directly the resource person.
Hello, sir.
Yes, sir.
How can you manage this temperature of this electric vehicles in the cold region, sir, like Kashmir, in that areas? How can it manage the temperature, maintain the temperature?
So there we are using a temperature management system. Heating coil is also incorporated because batteries are like a human being. Why I am saying this point is, if the human temperature goes to 0, it's a dangerous. If the human temperature goes to 100 degree above, that's also dangerous.
Okay.
So we need to take the feedback from the system. If it is very cold temperature, we need to blow the hot temperature, hot air. So that is being done from the heating coil. In the cold countries, if you go temperature, that's what the battery temperature is usually taken in the minus 20 degree also. They will operate perfectly. But if it goes beyond that, we need to blow the hot air for that.
Okay. Is there any like operating like in the air like cryogenic engines operating in 0 degree like that in the automotive industry will come up?
Sir, I don't have an idea.
Okay. Okay.
Thank
you. Any other questions from the participants? See, our coordinator promised our participants, the resource person will clear the doubts of the yesterday's presentation. Okay, she has attended a few questions. Our heartfelt thanks to today's the resource person, Dr. Sanjay Naik, for his effort, for putting the effort for giving the presentation for 2 sessions. Today he has given very the elaborative explanation about the EMI and EMC effect on electric vehicles by taking the various examples. Okay, how the EMI and EMC will cause effect on electric vehicle. Okay, by yes, also introduced the various the techniques available to measure the effect. On behalf of JNN College of Engineering, Shumaga, and Department of E&D, and on behalf of our coordinator, Dr. Surendra S. Okay, so I will thank you, sir, for your support and for being a part of our FTP. Thank you, sir.
Yeah, thank you, sir. Thank you so much. Lovely. So,
all the participants are requested to fill up the feedback form, and we will meet in the afternoon session. Thank you, one and all.
yeah, thank you.
Thank you, Sanjay Naik, sir. Thank you on behalf of E&D department. Thank you, sir. Hello. Okay, sir.
Okay, dear participants, with the same link at 2:30, we are going to meet again. Thank you.
ನಾ ಮಾತಾಡ್ತೀನಿ ಕೇಳುತ್ತಾ? ಹಲೋ. ಓಕೆ. ಎಸ್. Good afternoon, everybody. Afternoon session. Third session will be starting now. Okay. With the formal introduction of today's speaker and resource person of this FDP, Professor Muralidhar Killi. Okay. So I will hand over this one to Soumya madam to introduce our resource person.
Thank you, sir. So it's my pleasure to introduce our today's resource person, Dr. Muralidhar Killi. He is born and brought up in Andhra Pradesh. He received the BTech degree in Electronics and Communication Engineering from B.R. Siddhartha Engineering College, Vijayawada, India in 2008 and MTech in Electrical Engineering from the National Institute of Technology, Roorkela, India in 2012, where he did his PhD in Electrical Engineering in 2017. His research work has been published in IEEE Transactions on Industrial Electronics, IEEE Journal of Emerging and Selected Topics in Power Electronics. He is presently working as an assistant professor in the Department of Electrical and Electronics Engineering, MIT Manipal, since 2016. His areas of research interest include modeling, analysis and control of photovoltaic systems, power electronics, converter circuits, and energy storage devices. Sir has published many publications in national and international journals in conferences also. He also served as a reviewer in IEEE Transactions on Industrial Electronics for different modes like IEEE Journal of Photovoltaics, IEEE Journal of Emerging and Selected Topics in Power Electronics, IEEE Applied Energy, IET Renewable Power Generation, and it's a pleasure to have you here, sir. I will hand over the session to you, sir. You can start your presentation. Thank you.
Yeah, thank you for the introduction.
Sir, you can start your presentation,
Yeah,
sir.
sure. Are you able to see my screen?
Yes, sir. Yes, sir. Now it is sharing. Yes, sir. It is visible, sir.
Yeah,
You can put it to full screen, sir.
yeah.
Okay. Thank you.
So very good afternoon to one and all. Myself, Dr. Muralidhar Killi, presently working as an assistant professor in the Department of EEE, MIT Manipal. So today's topic is energy storage devices and its application to electric vehicle. So this is the outline of my presentation. Mainly we are discussing about what are the different types of energy storage devices we have and their importance in general. And also we will focus towards electric vehicle as well. And coming to battery and its terminologies, we'll briefly discuss about fuel cell and also ultra capacitors also with respect to electric vehicle application, and a brief history about the EV and its advantages over conventional vehicle and vehicle load forces and how to determine the power drawn by vehicle if the vehicle is moving at a particular speed or velocity. And coming to the determination of range of EV with respect about battery charging, protection, and management systems, that is BMS, with respect to EV. So coming to the energy storage devices and its importance, all of you are familiar with this. It helps in meeting the peak electrical load demands and provides time-varying energy management and elevates the intermittence of renewable energy sources. As you know, photovoltaic and wind are highly intermittent in nature. So definitely the energy storage devices play a key role in developing the renewable energy sources, and also improves the power quality and reliability and meeting remote and vehicle load demands. Right now we are talking about electric vehicles. So supporting the realization of smart grids and helping with the management of distributed or standby power generation and reducing the electrical charges at peak demand periods. So coming to the classification of energy storage devices, so there are mainly 5 types you can say. One is mechanical. Under that you have pumped hydro energy storage devices, then compressed air energy storage devices, and flywheel as well. So coming to electrochemical, we have secondary batteries, which are nothing but rechargeable batteries. So coming to under electrical, we have ultra capacitor, supercapacitor, and superconducting magnetic energy storage devices. Under chemical, we have fuel cell. Under thermal, we have thermal. With respect to electric vehicle, we are going to discuss about only secondary batteries, that is rechargeable batteries, and the role of supercapacitors and the role of fuel cell with respect to electric vehicle. Let's talk about the battery. As you are aware of batteries, we are having multiple types of batteries, right? So depending on the chemistry of the battery pack, the voltage of the battery cell will vary actually. So like we have lead acid, lithium ion, nickel metal hydride, or lithium phosphate, or different batteries, right? So let's talk about the terminologies which you should familiar with this before talking about the battery management system. So cell, coming to the cell, it is the fundamental or smallest unit of electrochemical unit or battery. So coming to the cell nominal voltage. So it depends on the chemistry of the battery pack. So suppose if you take the case of lead acid, its cell nominal voltage will be around 1.5 volts or 1.2 volts. Whereas nickel metal hydride where ranges from 2 to 3 volts. Whereas for lithium ion batteries, it ranges beyond 3 volts. So suppose depending on the voltage rating you want to design for a particular battery pack, so that many number of cells should be connected in series to achieve a certain voltage rating for a given battery pack. So coming to the cell nominal capacity, so it is about the amount of energy or charge stored in a battery pack. So it is units are ampere hour. So you have seen, I think, in inverters you have, right? 50 ampere hour or 100 ampere hours. So the rated with the rated voltage 24 volts or 12 volts. So that is about the cell nominal capacity. So coming to the C rate, it mainly we are going to discuss about C rate with respect to the charging and discharging rates. So what is the allowable charging current for a battery pack? So it mainly depends on the C rate. C is nothing but the capacity of the battery pack. Suppose if the capacity of the battery pack is suppose 100 ampere hour. So it is allowing a charging current of suppose C by 2. That means you can charge the battery pack at a rate of 50 amperes, not more than that. If it is allowing at a rate of 1C, then 100 amperes. If it is allowing at a rate of 2C rate, then you can charge with the current rating of 200 amperes, like that. So accordingly, your power electronic converter should be designed, right, while designing the charging stations or while getting the power from the grid. So specific energy, coming to the specific energy, it is about the maximum amount of energy stored per unit weight. So while with respect to electric vehicle, you have to choose a particular chemistry of the battery pack such that the chemistry of the battery pack should have high specific energy, so that the weight of the battery pack with the given rated power, we can minimize the weight of the battery pack. So it is helpful for the EV design. And coming to the energy density, similarly, so it is about with respect to the volume. So here also you have to go for the chemistry of the battery pack which has high energy density, so that it can occupy less space with respect to EV. So coming to state of charge, it is about the residual capacity to total capacity. Suppose if the capacity of the battery pack is given as 100 ampere hours, so residual capacity, suppose if it is 90 ampere hours, then SOC is 90%. If residual capacity is 10% only, 10 ampere hours, so then 10 ampere by 100 ampere hour, it is nothing but 10% SOC. So state of health, it deals with the what is the present condition of the battery pack. So it plays a key role with respect to the EV because so if as the number of charging and discharging cycles are increasing, that is the lifetime of the battery. So the range of the battery pack, the range of the electric vehicle also will degrade actually. So state of health should be monitored time to time. So we are talking about SOC benefits, estimation of SOC and its benefits, and why it should be accurate enough. So one point is longevity, right? So if SOC is accurately estimated, then you cannot go for overcharging or over discharge. The circuit will take care of it. So it can prevent the damage of the battery pack. So it results in lifetime mode. So performance, you can effectively utilize the battery pack without concerning about what is the SOC of the battery pack present. Because your SOC estimated by the device is accurate. So reliable. So suppose you are driving an electric vehicle, which is presently SOC is showing it is 90%. For the considered electric vehicle, you can drive a range of 100 kilometers, suppose. But after reaching a 50-kilometer distance, suppose the battery pack SOC is showing only 20%, then the system is less reliable. So accurate estimation of SOC plays a key role in many applications, and especially with respect to EV. So coming to density, you cannot, if SOC is accurately estimated, you can design optimally the battery pack. You cannot go for oversizing of the battery pack for a given power rating. So it can minimize the means density can be minimized, and economy also. So it can minimize the expenditure which is spent on the design of the battery pack. So coming to the fuel cell, we will discuss more in detail about the battery later stage. So let's talk about the fuel cell. So fuel cell history, it is started in 1839 by Sir William Groove. It is mainly reversing the electrolysis of water. So he thought of, is it possible to get an electrical current if you reverse the electrolysis? So that is the idea behind the generation of fuel cell. In 1950, Francis Bacon at Cambridge University demonstrated the first 5 kilowatt alkaline fuel cell. And in 1970, NASA had used 12 kilowatt alkaline fuel cell in space shuttle orbit. So this is the basic working principle of fuel cell. You have anode and cathode and separated by a membrane. So this membrane will act like a barrier for the electrons to flow from anode to cathode, whereas it will allow the ions to flow from anode to cathode or cathode to anode. So the electrons will flow from the external circuit only. That is, with respect to EV, it will flow through your load. The load is nothing but your traction motor. So coming to the anode reaction, you have H2, hydrogen is the fuel you are pumping towards the anode. So H2 will be divided into 2H plus and 2 electrons. 2 electrons will be released. So at cathode, oxygen will be supplied from the nature itself, surrounding by that fuel cell. So half O2 plus 2H plus and 2 electrons received from the load end to the cathode. So the overall reaction will be H2O. So the byproduct in the fuel cell is H2 along with the generation of the electricity. The overall reaction is H2 plus half O2 is nothing but H2O. So that is about the working principle of fuel cell. So certain advantages are there with respect to the fuel cell. So we'll discuss. Coming to the types of fuel cell, you have multiple types of fuel cells are there. So that is, one is proton exchange membrane fuel cell, PEMFC. Under that you have direct formic acid and direct ethanol fuel cell, And another one is alkaline fuel cell and phosphoric acid fuel cells and molten carbonate and solid oxide fuel cell and so on. So coming to the advantages of the fuel cell. So you can see fuel cell, you have one thing is that, so you should have hydrogen fuel tank, right, in the electric vehicle with respect to electric vehicle. So tank empty, you can refuel it at the hydrogen station in a few minutes. But whereas if you take the battery-based electric vehicle, so if the battery has to be recharged, if there is no swapping station is available, so definitely you have to go for the recharging one. So which will take hours to charge the battery, maybe 2 hours or 3 hours. So depending on again the rating of the battery pack. So again that is what the long charging times. Whereas with respect to fuel cell based electric vehicles, within few minutes you can fill your hydrogen tank, you can go just like a conventional vehicle which is running by petrol or diesel. So that is one of the advantage, but certain drawbacks are there. So that is one is lack of infrastructure with respect to India mainly. So you will find fuel cell based electric vehicles mainly in California, Japan, in Europe countries, right? So Toyota is come up with that fuel cell based electric vehicle, that is Mirai, and some other companies also focusing on the fuel cell based electric vehicles. But Tesla is focusing on only battery based electric vehicles, and they are generating usually the lithium ion cells for supplying for the electric vehicles. So coming to the supercapacitor or ultra capacitor, it has, so it is like it will fill the gap between the conventional electrolytic capacitors and rechargeable batteries. It has high power density, and the problem is it has low energy density. So that means it can quickly deliver huge amount of power, but not for long time. Within few seconds, it will exhaust. So this feature will be applicable during the acceleration of the electric vehicle. You see, if you are suddenly increasing the velocity of the electric vehicle, so it has to draw a huge amount of power from the battery. So it leads to quick discharge of the battery pack. To avoid that, if you have ultra capacitors in support with the existing battery pack, so it can maintain the healthy condition of the battery pack, because ultra capacitor can provide huge amount of power for a short duration of time, right? So you no need to rely on the battery alone. So that is one of the advantage of the ultra capacitor. Not only that, during the regenerative braking, right? If you are climbing down from the hill to the electric vehicle, through the electric vehicle, so during that you can store the energy. So your motor itself will act like a generator during that. So the generated energy will be stored into the ultra capacitor rather than storing directly into the battery. So that is one of the advantages of the ultra capacitor. And also it has a long time, lifetime is more compared to the rechargeable batteries. And the problem is the capacitance will be high in farads, tens of farads, but the voltage rating of this ultra capacitor will be very less, might be 2.5 volts. So to get a rated voltage, you have to connect just like a electrochemical cells which you are connecting in series. The ultra capacitors also you have to connect in series to get a rated voltage. And also the cost of the ultra capacitors is also high compared to the conventional capacitors. So coming to the electric vehicle. So as it is covered in the previous sessions, I hope. So what are the motivating factors if you look into the EV? So one is reduce emissions and improved efficiency. How the efficiency is improved also will pictorially we can take it in the coming slides. And also greater consumer market appreciation, and it is a green technology, right? So you cannot completely say it is green technology until and unless you are recharging your battery pack of the electric vehicle with the renewable energy resources. So you have electric vehicle and you are recharging the battery pack with the grid. The grid power is generated from the coal, suppose. Then you cannot say that this technology is a green technology. Clear? So that is one of the concern everyone needs to look into it. So a brief history of electric vehicle you can see. So it started in 1890s with the lead acid battery based electric vehicle, so by replacing the internal combustion engines. Later in 1980s, General Motors thought of deciding coming up with an electric vehicle, and they have launched in 1996. That is General Motors Electric Vehicle 1 in Southern California. So later in 2000, AC Propulsion has developed a vehicle which is known as PG. So let's look into the kinds of electric vehicles you have. One is in locomotives and golf carts and forklifts, and also nowadays you are seeing the electrical buses also, and in elevators. So kinds of cars, we have luxury cars. So hydrogen fuel cell based electric cars. We have solar racer. So because you are charging the battery pack of this vehicle with the solar panels. So we can say it is a completely independent. So this is an hybrid. It can run with the battery pack along with the conventional fuel. So this is neighborhood electric, and this is Massachusetts Institute of Technology city car. And this is full size battery based electric car. It is complete electric. That is powered by battery. So coming to the electrification, if you see, so conventional vehicle has IC engine which is powered by fuel, as you know. So coming to the hybrid, we have along with the IC engine, we have electrical motor or generator, which is powered by the battery pack. So here you have the choice of fuel actually with the hybrid vehicle. So coming to the battery-based electric vehicle, there is no IC engine. We have only completely electrical motor or generator, which is powered by the battery pack. So let's look into the energy loss with respect to city driving for a conventional vehicle. A conventional vehicle means you have IC engine, which is run by fuel. If it is fully filled, so you have 100% fuel, and conventional IC engine losses are 76% and standby losses are 88%. So overall losses are 84. So overall efficiency is only 16%, right, for conventional vehicle. So under this city driving, yes. So drive line, you have drive line losses are 3%. So overall efficiency is coming to 13%. So fuel tank is 100%. So overall efficiency is only 13% for a conventional vehicle. So this 13% will be utilized for aerodynamic drag force and rolling resistance and braking of the vehicle. So coming to the electric vehicle, so you have no fuel here, only it is driven by the battery. So if it is fully charged, 100% energy, and you have electrical motor, so electrical motors are highly efficient, right? If you consider 90% efficiency, so only 10% losses. You have 90%, and at least if you consider driveline losses as 14%. So previously driveline losses are considered less, but here it is driveline losses are increased because of the vehicle dynamics will change, because the weight of the vehicle also will increase because of the existence of the battery pack and other factors. So the driveline losses are 14%. So overall efficiency is still, it is much higher than the conventional vehicle, that is 76%. Whereas for the previous it is coming only 13%. Then now you will be surprised, I think. So by seeing this figure, 76% and 13%. So why we are not still, we don't have any electric vehicle in the market, means huge, right? Still everyone is going for the conventional vehicles, not for the electric. So maybe by 2030, maybe every conventional vehicle will be replaced with the electric vehicle. Let's hope for that. So what is the reason for that is because you have batteries. So batteries are only the main constraint here. So certain drawbacks are there, right? The cost of the electric vehicle also will be more compared to the conventional vehicle, right? If you take the in Indian market, like suppose Tata Nexon EV, so its cost is around 13.9 lakhs, right? Whereas conventional vehicle will be much lesser than that. So the cost is high because of the battery pack and also limited range. Tata Nexon has a range of around 300 kilometers, right? So means a lack of charging stations at frequent points and lifetime of the battery pack. So many constraints are there. So that is one of the concern about the electric vehicle. So many researchers are looking after batteries. So one thing is that power electronic converters, advances in power electronic converters is helping a lot for an electric vehicle. So that is what. So let's look into the well to wheels efficiency. So suppose you have an electric vehicle and a conventional vehicle which is running by fuel, right? And this electric vehicle is charging with the conventional grid, suppose, which is clear. So here fuel is there. So fuel is used for generation of the electric power. And whereas here the same fuel will be refined and will be transported nearer to the petrol stations and will be filled to the fuel tank in your vehicle. So let's see the efficiency. So here the generation efficiency is 33%, and the transmission efficiency is 94%. So overall efficiency is 31% here. So we're charging the battery pack of the electric vehicle with the existing grid. So the plug to wheel efficiency, as you already seen, that is 76%. So overall efficiency is coming as 23%. Let's look into the conventional vehicle. So you have refining. Refining efficiency is 82% and the transmission. So from the fuel, it should be brought to the nearest petrol station. So you have to spend some amount of time, amount of fuel, right? So efficiency is 98% here. So overall efficiency is 80%. So pump to wheel efficiency we already derived, that is 16%. So overall efficiency is 13%. So still the electric vehicle has advantage over the conventional vehicle. So 10% efficiency higher than that. So this analysis only for if you are charging the battery pack with the conventional grid. Suppose you are relying on the renewable energy sources for charging the battery pack of the electric vehicle. So then you will see a greater advantage than the conventional vehicle. So benefits of EVs and plug-in hybrid electric vehicles, you know it because it might be covered in the previous sessions. So it is more efficient and lower fuel costs. This is one thing you have to discuss. Lower emissions, simpler transmission, and fewer moving parts will be less. So the maintenance will be less. So you have the fuel choice. If it is, we can charge the battery pack with the conventional fuel-based grid or with the renewable energy resources. Countries can like India can be, if it is free from energy, then our economy also will be improved, right? So coming to, have you thought of how much amount of money can be, means what will be the per kilometer, what will be the expenditure if for an electric vehicle? So suppose if you see, suppose 10 kilowatt hour of energy is taken from the grid. Suppose 10 kilowatt hour means 10 units. Suppose unit price is 5 rupees. That means you are spending a amount of 50 rupees. So suppose with the 10 kilowatt hour of battery pack, suppose you are covering a distance of suppose 50 kilometers. So per kilometer you are spending an amount of 1 rupee approximately, right? With the electric vehicle. So whereas if you look into the conventional vehicle, you can count. So what is the mileage of an vehicle, conventional vehicle, and per kilometer? So you can come up with it. You will see a great change. Definitely you will appreciate the electric with respect to the cost. Means you are spending on the fuel. So coming to the challenges of the electric vehicle, we have limited range. That is what I said. And that is main constraint is with respect to the battery. We can increase the range by increasing the battery pack, but definitely the cost will increase and also the weight of the vehicle also will increase and you need more space. So that is one of the drawbacks. The long charge times, as I said, it will take hours. So suppose if you take Tata Nexon or Mahindra Yuvato, so zero if it is fast, you are using fast charging. So 0 to 80% charging, it will take 60 minutes approximately. That is what they are claiming. So if you are charging with 15 amperes charger like conventional at home, then it will take 5 hours to charge from 10% to 90%. So another thing is high initial cost, as I said already, compared to conventional vehicle, the cost of the electric vehicle is high because of the battery pack and other. And battery life, so each battery has certain lifetime, like 1000 cycles or 2000 cycles or more than 2000 cycles, depending on the chemistry of the battery pack. So lead acid batteries will have 1000 life cycles, lithium ion batteries may have more than 2000 life cycles. So mainly nowadays, all electric vehicles are run by lithium ion based battery. So consumer acceptance, so consumers should be ready to change, means to come up with the electric vehicle, right? If there is no consumer acceptance, we cannot increase the usage of electric. So grid integration, this is one of the constraints with respect to the power system point of view. So suppose you don't, in nowadays, you will not find any electric vehicles in your street or in your cities. Very limited number of electric vehicles you have. So there is no means much concern about the loading on the grid. But suppose by 2030, everyone is having electric vehicle at home. Definitely, you have to charge the electric vehicle at home during the night at least for 2 hours or 3 hours or whatever. So it will increase the burden on the load, right? So whether the existing grid can support that much load or whether the existing distribution lines can support to deliver that much amount of power and how to deal with this. So this is one of the research area to look into it if you are related to power system. So let's look into the vehicle load forces and power. So this thing we are mainly discussing to come up with design of battery pack and determination of range of an electric vehicle, if you know the specifications. So mainly there are three forces acting on the electric vehicle. One is aerodynamic drag force, FD, that is given by half rho A CD V square. So rho is the air density, A is the cross-section area of the vehicle, and CD is the aerodynamic drag coefficient, and V is the velocity of the vehicle. The second one is FR, that is rolling resistance force. FR is CR into mg. CR is the rolling coefficient of the vehicle, and m is the mass of the vehicle, and g is the acceleration due to gravity. So coming to the third one, that is climbing force, it is given by mg sine theta. Theta is the inclination of that vehicle, means road. So the overall vehicle load forces are FD plus FR plus FC. So how to come up with the vehicle load power if the vehicle is running with a particular speed? So that is force times the speed of the vehicle. So overall force is FD plus FR plus FC into V. So if you know this vehicle load power, so that means if the vehicle is going with a certain speed, we can come up with what is the vehicle load power that is drawn by that vehicle. So provided you know the FD and FR and FC. So these coefficients you should know, then only you can calculate this all the vehicle load forces. So if you increase the speed of the vehicle, the power drawn by the vehicle also will increase. So these are some characteristics. We can see that for 5 different vehicles like Nissan Leaf and Tesla Model S, Toyota and Chevy, we can see that for different vehicles how the vehicle load forces are varying with respect to speed of the vehicle. For the same speed, each vehicle has its own vehicle load forces. It's all because of the vehicle dynamics. Its mass might be different, and also aerodynamic drag coefficient might be different, rolling resistance might be different, right? So because of those factors, the vehicle load force also will vary from vehicle to vehicle. So the designers will always look for to reduce the vehicle load forces in designing the vehicle. So once you have the vehicle load forces, how to come up with the vehicle load power? Just multiply with the velocity of the vehicle. So F into V. So you will come up with the vehicle load power. That is in kilowatt. It is mentioned here. So if the vehicle is, suppose if it is running at a speed of 150 km per hour, then the vehicle needs approximately, like if you took the Tesla, it needs approximately 40 kilowatt of power. So if the speed increases, then the vehicle load power drawn by that motor also will increase. So let's see how the vehicle road power and energy consumption examples here. So we have different models are there, and the vehicle speed is given. Let's see here for 1 minute. So the vehicle is running at a speed of 30 km per hour, and the vehicle load force is load power is 1.44 kilowatt if it is running with 30 km per hour. So the energy consumption per kilometer, that is, we will come up with 48 watt hour per kilometer. It is nothing but 1.44 upon 30. We will come up with 48. 1.44 is kilowatt. Okay. So similarly, if it is running at a speed of 60, then 4.7 kilowatt upon 60 will come up with 78. As the speed of the vehicle increases, the energy consumption per kilometer also increases. That means the mileage of the vehicle will reduce, that is range. Range of the vehicle will reduce if with respect to the increase in the speed of the vehicle. So that's why they will mention whether you want to move the vehicle in sports mode or eco mode. Accordingly, the range of the vehicle also will change. So the same you can see for different vehicles how it is there. So let's look into one numerical for determination of range of an electric vehicle. So here some specifications are given just to get an idea of it, instead of reading the details which are given by different vehicles. If you have this idea, you can understand in a better way. So an electric vehicle has the following attributes. Here it is given as drag coefficient of the vehicle is 0.25. And the vehicle cross section is given as 2.5 meters square. And the available proportion of the energy of the battery pack. Energy of the battery pack is given as 20 kilowatt hour. So let the density of the air is 1.2 kg per meter cube. And instantaneously at a vehicle speed of 120 km per hour, calculate the aerodynamic drag force, that is FD, power, range, while driving in. Case 1 is under calm conditions with no wind. Second one is case 2, that is windy conditions with a 12 km per hour tailwind. So there will be 2 winds, one is headwind and tailwind. So here it is mentioned tailwind. So coming to FD, as you know, that is half rho A CD V square. So all the specifications are given. The vehicle speed is given as 120 km per hour. If you substitute that, you will come up with 416.66 newtons. So PD, once if you know FD, PD is nothing but FD times the velocity. So you will come up with 13.88 kilowatt. this much amount of power is required by the vehicle to move with a velocity of 120 km per hour. So the range of the vehicle is, so provided the energy of the battery pack is 20 kilowatt hour. So EB times the speed of the vehicle upon PD will give the range of the vehicle. That is 172.9 kilometers under calm conditions. That is no wind. This is for case 1. So if there is a tailwind, so the aerodynamic drag force is given by half rho a CD. The resultant speed of the vehicle is force acting on the is V minus VA square. So the aerodynamic drag force will reduce here. So definitely the power drawn by the vehicle also will reduce. So definitely the range will increase, right? So it is increased to 213.33 kilometers. So you can see, suppose if it is mentioned case 3, windy conditions with 12 kilometers per hour headwind, suppose. So then aerodynamic drag force is half rho a CD V plus VA whole square. So the aerodynamic drag force will increase. It will be more than this 416. So the power also will increase. It will be more than this 13.88 kilowatt. The range will be much lesser than this 172.9 kilometers. So this is considered just one example only. Here it is considered only the aerodynamic drag force. But practically you have to look after the all forces acting on the vehicle. So it is just to get an idea how to come up with a range of the electric vehicle. So provided it is running at a certain speed and the present energy of the battery pack is so and so. Coming to battery charging, protection and management systems with respect to EV. So coming to the battery charging, as you are aware of it, there will be 3 modes of charging. One is for any battery. One is constant current charging and constant voltage charging, and last one is float charging or trickle charging. So constant current charging is like, so there below 90% or whatever that is specified by the manufacturer depending on the type of chemistry of the battery pack. So up to reaching certain SOC, you are going to charge the battery pack with the rated current. Might be 1C or 2C, depending on its support, how much current it can support. You cannot overcharge the battery pack. So if this is DC charging, there SOC of the battery pack will increase. Battery pack voltage also will increase. Here it is considered only for one cell actually. Okay, that's when the battery pack is fully charged. So there should be some counter action to take place to overcome this self-discharge. Self-discharging you cannot avoid, but whatever amount of self-discharging is taking place, you can pump the charge into the battery pack, the same amount of charge, which is self-discharge, so that the battery pack will remain at 100% for your next drive. So that is about the charging. And the specification will be provided by that battery pack manufacturer. So you cannot charge the battery pack more than the rated current. and also it should not be overcharged or it should not be over discharged also to maintain the state of health of the battery pack. So here let's look into the determination of battery pack charge, current and power for this given problem. Just to give you an idea about it. A 24 kilowatt hour battery pack can be fast charged from 0% to 50% SOC in 1 hour, that is 60 minutes. To determine the approximate charge current and power in order to achieve this charge time, so assume that battery pack voltage is 360 volts. So 50% is SOC, right? So actual battery pack capacity energy is 24 kilowatt hour. So the nominal pack size is 24 kilowatt hour. So 50% of it is 12 kilowatt hour because you are charging to 50% SOC. So thus the battery has to be recharged at an average rate of approximately 12 kilowatt because it is charging over a 1 hour. If it is to be charged in 30 minutes, then you have to charge at an average rate of 24 kilowatt. If the nominal battery pack voltage is given as 360 volts, right? So the amount of charging current should be 12 kilowatt upon 360 volts. So you will come up with 33.3 amperes. If it is to be charged within 30 minutes, half an hour, then the charging current will be 66.6 amperes. So why we have to look after this is because, so depending on this power rating and the charging current, the power electronic converter should support for this amount of power and this much amount of charging current. So the power electronic researchers should look into this, right? So they should know all this set of instructions. So then only they can optimally design the power electronic converters while designing the charging stations or while charging the electric vehicle from the existing grid. So coming to the battery failure and protection, we have, so this is one of the concern everyone should take care of it, right? So like fuel. So batteries can be a source of catastrophic failure, or it may result in life-threatening as well. So suppose during the collision or any accident, suppose unfortunate thing happen, it should not emit parts, fire or toxic other gases. So care must be additionally taken in manufacturing and also during transporting, and recycling of the batteries also should be taken care. As you know, so each type of chemistry has certain number of life cycles or lifetime. So 3 to 5 years or more than 2000 cycles or whatever. So after its lifetime is over, so certain agencies or certain bodies should look after the recycling of the batteries as well. Should not be dumped somewhere else. So similarly with the photovoltaic modules also, right? So we have photovoltaic modules lifetime of 25 years. After 25 years, they should be recycled properly, right? Otherwise, it is very difficult to manage. So another thing is that many safety standards exist to define the level of danger from an automotive battery, and also penetration of pack, suppose during the accident or whatever. So lithium-based materials, it may result into fire. So crush. A battery pack must not become hazardous if it is crushed in a collision. So thermal stability, you should be very careful in maintaining the temperature of the battery pack. It will be safe around 80 degrees Celsius. So there should be some cooling mechanism to maintain the temperature of the battery pack. Otherwise, it may lead to thermal runaway of the battery pack. So overcharge or over discharge, as you know, so this may lead to raise in the internal temperature of the battery pack. And also external short circuit. If anything happens, externally short circuit, then there is chance of huge power dissipation internally, and which may lead to increase in the temperature. So coming to the battery management system. So battery management system, especially with respect to the electric vehicle, it should look into the following parameters. One is it should be in a position to monitor the voltage, current, power, and temperature of the battery pack. So it should accurately estimate the SOC, state of charge of the battery pack, and also maintain a healthy battery and conduct diagnostics. And here, one thing is that as the number of life cycles increases, means charging and discharging cycles are increasing, so the parameters in estimating the SOC and state of health should be updated. You should not keep the old parameters. Then only you can get an accurate value of the SOC, right? So this also should be taken care while designing the battery management system for an electric vehicle. So if you keep the same parameters while designing the battery pack, whatever, after 1 year or 2 years, you will not find the same thing, right? So the range will fall down, and SOC also, if it is not accurately monitoring, then the customer will face the problem, right? Who is driving that electric vehicle. The protect against the fault conditions such as overcurrent or overcharge, undercharge, or short circuit, and excessively high or low temperatures as well. So it should be in position to control power up or power down and recharge as well. And there should be communication with the vehicle. So that is what should be the speed of the vehicle so that this much range we can cover with the existing condition of the battery pack. That is, what is the state of charge of the battery pack, what is the SOH, what is the ambient temperature, what is the temperature of the battery pack. So everything should be in communication with the vehicle and balance of the cells at last. So even though the battery cells are manufactured from the same company and are of same materials, whether it is lithium ion or lead acid or nickel metal hydride, so there is a chance of imbalance in the cells. One cell may be completely charged, might be suppose 90%, other cell might be suppose if it is 50% SOC. It should not happen, but unfortunately if it is happened suppose, then that kind of packs we cannot neither use or means neither you can charge that battery pack nor you can discharge also. It will not support. The weak cell will not support for either for charging or discharging, because one cell is completely charged and another cell is completely discharged suppose. So that is the scenario. So how to overcome that problem is there are balancing of cells is there. Certain methods are there like active balancing and passive balancing methods are there. So it is also a part of battery management system. So especially with respect to the EV, so care must be taken while designing the balance of the cells. Okay, thank you. If you have any queries, you can pose your questions.
Madam, you are audible. As somebody posted in YouTube, just check, madam.
If you have any questions, please post your questions. Difference between SOC and SOH. State of charge is about the, suppose as I said, total capacity of the battery pack is 100 ampere hour and the load is drawing, suppose certain amount of 50% of the energy has been utilized by the load. So what is the amount of energy is left? So that is 50%. So what is the present status of the battery pack? Whether it is fully charged or 50 percentage of amount of energy has been drawn by the load, or 10 percentage of amount of energy is left in the battery pack. So that is about the state of charge of the battery pack. So coming to state of health of the battery pack, so while designing the battery pack modeling, so you will estimate certain parameters of the battery pack. So those parameters will change with respect to the increase in the number of charging and discharging cycles. So even though suppose, as I said, so you have purchased certain new mobile or new battery pack. After 1 year, even though it is fully charged, so it will not run that load whatever previously you are using. Suppose previously in the beginning of your life cycle, it is running for 3 hours, suppose your inverter. After 1 year, you will end up with only after 1 hour, it is completely drained out. So that is all about the state of health of the battery pack. So especially with respect to the electric vehicle, this battery parameters has to be onlinely, for time to time, it has to be updated in order to get the present condition of the battery pack. So that effectively you can determine the range of the electric vehicle after 1 year or 2 years. So now if you see Tata Nexon is claiming 300 kilometers. So will you expect same 300 kilometers after 1 year or 2 years? No, definitely. So it's because of the state of health of the battery pack. So there are certain methods are there to estimate the state of health as well. So mainly the RB, internal resistance of the battery pack, they will update it. Simplest way actually, but certain other parameters also you should look out while modeling the battery pack.
Hello, Muralidhar sir, can you hear me? Hello? Okay. Oh, yep. Madam.
Anyone has other questions to ask? So as I have said in the problems, certain problems are there, right? About the determination of range of the electric vehicle with respect to the speed of the vehicle and the present condition of the battery pack. So as you see, if you see Mahindra Evo has a battery pack capacity of power energy density of around 20 kilowatt hours approximately. Its range is around 180 kilometers. That is what they're mentioning. So coming to the Tata Nexon, it has 30 kilowatt hour energy battery pack. That's in definitely range will be higher, right? So their claim is about 300 kilometers. So it's all about the energy of the battery pack. Grid integration
Ah,
of the vehicle. So whether how to cope
grid integration.
with the existing grid with the
Okay,
increasing
okay, sir.
that is with respect to
Okay,
the
sir. Okay.
power
Hmm.
perspective.
Okay, sir.
And
Okay,
another
sir.
is power electronic converters.
Hmm.
There is a ample amount of scope for the power electronic
Hmm.
converters with respect to the electrical. So is there any other
Okay, okay.
topology can be designed
Yeah.
so that
Uh-huh.
efficiency of charging station or battery pack can be improved. So the
Okay.
losses can be while
Okay.
discharging the battery pack or charging the battery pack. So the
Okay, okay, sir.
advancement.
Okay, okay. Sir, okay, sir. Once again, if any queries comes, we will just send to your email, sir. You can answer. So, with okay, sir. Okay. With this, the session concludes. And once again, thank you, sir. Okay. Thank you for this one. Okay, sir. Bye, sir. Thank you. Good evening, sir. Okay. The session ends, sir. You can log out now. Okay, sir. ಇಲ್ಲಿ ಕೊಡ್ಬೇಕು ಅದು ಕೊಡಕ್ಕಾಗಲ್ಲ
I think if nobody has having further questions, I can sign off, I think.